Let us find the rank of the matrix. We'll do it by applying elementary row operation and column operation. So the procedure is pretty simple. Apply elementary row and column operation to get maximum number of entries equal to 0, and then count the number of non-zero entries. That will give us the rank. So we want to find the rank of this matrix. Somehow we want to apply elementary operation so that we get maximum number of entries equal to 0. Let's try to get this number to be 0 and this one to be 0. Can we do it? Yes. We apply the operation. R2 is equal to R2 minus 4 times R1. In other words, we'll be subtracting 4 times the first row from second row. Once again, we'll be subtracting 4 times first row from second row. So 4 minus 4 is 0. First row we copy as it is. 4 minus 4 times 1 is 0. 5 minus 4 times 3, that's minus 12. 5 minus 12 is minus 7. What about the other one? The third, how do I render this number 2 to be 0? We'll apply the operation. R3 is R3 minus 2 times R1. In other words, we'll be subtracting 2 times R1 from R3. Let's do it. So 2 minus 2 times 1, that's 0. 7 minus 2 times 3, that's 7 minus 6, which is 1. Okay, we got those two entries to be equal to 0. Can we get more number of entries to be equal to 0? Yes. We simply apply the operation. R2 is R2 plus 7 times R3. In other words, we are adding 7 times third row to the second row. Once again, we are adding 7 times third row to the second row. We don't change third row. We write third row as it is, 0, 1. We add 7 times 1, that's 7. 7 minus 7 is 0. That's 0. What about the first one? Can I render this number 3 to be equal to 0? Yes. We simply apply the operation. R1 is R1 minus 3 times R3. Once again, we subtract 3 times third row from first row. 3 times 1 is 3, and 3 minus 3 is 0. And well done. We got two numbers to be equal to non-zero. Rest of them are all 0, and we can't do it further. Therefore, rank of given matrix is 2. And we did it simply by using elementary row operation. We did not use column operation at all. Let's do one more example. Once again, we want to render maximum number of zeros as possible. We see that we can reduce this number to be 0 by applying the operation. R2 is R2 minus 3 times R1. Once again, we subtract 3 times the first row from second row. So first row we copy as it is. 3 minus 3 is 0. 5 minus 12 is minus 7. 7 minus 6 is 1. Okay, so we got this entry to be 0. What about some more entries? Can I get other entries? Oh, it's easier to get this one to be 0. So we apply the operation. R1 is R1 minus 2 times R3. So we are subtracting double the R2, double the second row. We are subtracting double the second row from the first row. 1 as it is. 4 plus 14, that's 18. 2 minus 2, that's 0. 0 minus 7, 1 as it is. You see that we don't have much scope of increasing number of zeros by using elementary row operation. So what we do is we apply elementary column operation. So we apply the column operation. C2 is C2 plus 7 times C3. So what we are doing is we are adding 7 times third column to the second column. That gives us 0, 18, and third column we keep it as it is, 0, 1, and first column we keep it as it is. We got some more number of 0. What about some more? Yes, C2 is C2 minus 18 times C1. When we do that, we'll be left out with 0, 0, 0, 0, 1, 1. Oh, once again we got only two number of non-zero quantities. Therefore, rank is equal to 2. Let's take another example. 1, 2, 2, 4. Let us find the rank of this matrix. We apply the operation R2 is R2 minus 2 times R1. When we do so, 2 minus, that means we are subtracting double the first row from the second row. 2 minus 2, that's 0. 4 minus 4, 0. Oh. Next, we simply apply the operation. C2 is C2 minus 2 times C1. Once again, C2 is C2 minus 2 times C1. In other words, we are subtracting double the first column from second column. So 2 minus 2 is 0. These are 0 as it is, 1. Therefore, rank equal to 1.